Okay, so I'm just going to record ad hoc video. Maybe it might turn into a series, but it is still me learning AI, so it counts, right? Um, Today I want to talk about something called like task decomposition. Okay, and this is actually something that is essential for agentic AI, and a good example of agentic AI would be something that uh, leverages AI to control your computer. For example, something like an ID like Cursor, right? For example, uses agentic AI to write code for you. Or you could also use it for computer use. So something that can control your computer. And I've been very interested in this aspect of it, the computer use. Um, I've been doing a lot of work in trying to get AI, like a vision language model, to be able to understand what's on the screen, so that it can help an agent know what to click, like what button to click on, or like what text to type into a text field, and so on. So, um, generally, the pattern for agentic AI usually involves something like planning, and then basically then taking that plan and acting on it. But to act on it, you need to have like visual recognition of screenshots, right? And then also being able to control the UI. So this part, I guess, is out of scope for what I want to talk about today. I want to talk about this part, the planning part, and that's basically the task decomposition aspect of it. So, um, let's say suppose I have a specific user prompt, right? Um, let's just say this is going to be fed into some sort of AI agent. If I had like a user prompt saying, uh, let's say, make the font size bigger, right? Let's just say 12, or let's say 18 point. I think by default things are like 11. But let's have this as a single prompt here. And um, what happens is that when this user prompt goes into a system, an agentic system, that actually gets decomposed into steps. And you can imagine this is actually a very, I guess, high level overview of the main goal that the user is trying to achieve. And so, in order to make this overall goal actionable, we have to be able to decompose that into a series of smaller steps. And so, one might imagine that in order to make the font size bigger to, let's say, 18 points, for any arbitrary application, but for this example, Microsoft Word, um, we can start out with something like this. Uh, um, Ensure that the document editing view is visible. Okay, so basically the editor panel, and then the next would be navigate to the toolbar, locate the font size drop down, click on the font size drop down, and then maybe something like scroll to find 18, click on 18, and then inform user font has been changed to 18. Maybe this is not even like, maybe this is not even required. Let's just get rid of this. So like by clicking on 18, it means that we've already made the font size bigger, right? To up to 18 points. So this will be our input. Like a user prompt saying, okay, make the font size bigger. And then what we would get back here is decomposed tasks, a set of tasks, right? To be able to achieve this overarching goal. So that's what task decomposition is. And so normally when we do this, we don't really program something to take something like this and turn it into this. Rather, nowadays we can use an LLM to assist us in being able to take this sentence here, this overarching goal. It could even be like longer, and decomposing it into the series of digestible steps. And how that's going to work in the agentic system is that when these decomposed tasks come back, the agentic system will probably be doing something like splitting this entire payload by lines and stripping out these bullet points, and then just like in a queue processing each one of these instructions one by one. So that's like one sort of way we can use this type of information. So we're not going to be able to kind of like at least get the entire set of combinations here. Like for example, what if this changes to be 2024, for example? And so are we going to actually write 24 here? Like we're going to make some sort of if else statement and then generate something that corresponds to 24 as opposed to 18? Not really. And that's the reason why an LLM would help here. Now, I asked again, I asked Copilot here using GPT-5. Okay, so the prompt was, give me an example of how I can create a single training example for a small language model that specializes in task decomposition. Let's say the purpose is for Agentic AI for GUI navigation. So let's see what this answer is. So Copilot says, okay, well, that's a great question. This is exactly the kind of scenario where carefully crafted training examples make all the difference. Since you're aiming for task decomposition in the context of agentic AI for GUI navigation, the training example should show the model how to break down a high-level instruction into a structured sequence of smaller actionable steps. So here's a concrete example of how you might format a single training example. So here's an example to say, okay, open the email app, find the latest unread message from Alice, and reply with, got it, thanks. So given this overarching goal, this single prompt, we want to be able to take this and then turn that into the series of actionable steps that I've been talking about, usually through the use of an LLM. So an LLM will then spit out these series of steps to achieve that specific goal. So the task here that the LLM interpreted it as is reply to Alice's latest unread email. So the series of steps here would be to first step is to locate and open the email application icon on the desktop or taskbar. The next one would be to navigate to the inbox view, then filter or identify unread messages, search for sender Alice among unread messages, select the most recent unread message from Alice, click reply button in the GUI, type the message, got it, thanks, which is basically what the user asked for here. Got it, thanks. And then click send to complete the reply. Okay, so all this can achieve this single prompt here. And you could assume that each one of these steps here that get decomposed, they correspond to a training example for the vision language side of things. So anyway, so why this works. This is what Copilot thinks why it works. So clarity. Each step is atomic and GUI actionable. Okay, so yeah, we have GUI actions that we can that are within each single step here. I would say like search is kind of like a typing thing. Yeah, and locate is probably like a navigational thing, and open would be click. But I wouldn't even say that that's like something that you have to like stress out about. You'd be surprised that LMs are a lot smarter than we generally give them credit for when we do these things. So hierarchy. So the model sees the relationship between the high level task and the granular steps. Consistency. Using a structured format like JSON makes it easier for the model to learn patterns. And then you have generalizability. So the same schema can be reused for other GUI tasks, opening a file, adjusting settings, or filling out a form. So when it comes to like decomposing this task or goal here into a set of tasks, you don't really have to have a schema like this. You can actually absolutely just decompose it into like a list of bullet point natural language instructions, just like this too. It just depends on like how you want to be able to use it on any downstream tasks. And when we say downstream tasks, what I mean is using it, having the vision language model use these individual instructions from the task list. Okay, so like tips for building our data set, right? So we want to keep the inputs natural. So again, the input here would be the prompt, right? The prompt. And then we want to keep the output structured. I mean, I would say that something like this is also structured, right? Like you have bullet points here, markdown bullet points. So that probably counts as structured. Okay. And then include some variety, different apps, different verbs, different levels of complexity, and then considering error handling. Okay, if no unread messages from Alice exist, then stop and notify the user. Okay, so my follow-up question was, the LLM during training should then know how to pattern match and replace the proper words that generally are dynamic, right? For example, proper nouns and such. And that is true, exactly. So we have the right intuition when we train a small LLM for task decomposition. We generally don't expect it to memorize the specific names like Alice or Outlook. Instead, it's just going to learn a pattern. So in order to learn a pattern, we have like two ways to do this. We can slot abstractions. So we can actually provide placeholders. Instead of like using Alice, we can just replace with like contact name with a square bracket, and LLM should figure it out. So something like this. This is like the equivalent, right? So type reply text would be like type got it, thanks. App name would be Outlook, which is an email application, and so forth. Now that's not really required either, too, right? This is something that we can just do to kind of generalize better. But really, you can also have many examples where instead of using Alice, you could use Bob, you could use Sarah, you could use John. You can just have this variety, and even then the model should be able to learn and understand that, okay, well, these are always changing, so I shouldn't really lean too hard into thinking that that is something that I must always respond with. Okay, so knowing that, let's actually kind of use a model here, local model, to be able to kind of produce or automate that task decomposition given some sort of prompt. So again, most LLMs are pretty smart right off the bat, so you don't really need too much training. Just like a good prompt could possibly get you there already. But if a goal is very domain specific, then maybe that requires some fine tuning. I'm just going to fine tune just for the sake of fine tuning. Even more extreme, I'm going to try and fine tune very small language models. And I'm purposely using this very weak laptop just to see how far I can get without fancy hardware. So here I have Qwen 3 1.7b, so it's a 1.7 billion parameter model, and we're going to attempt to prompt it so that it can give us structured tasks. Okay, so I'm just going to start a new one, and if you know Qwen 3, it's actually a hybrid model, so I don't want thinking, right? So no think is how you would start any sort of prompt to not have Qwen 3 go through a bunch of thinking tokens before producing output. That's generally pretty useful if you want something quick or your scenario doesn't really require a lot of reasoning. So I'm going to use, actually, this is an example, a good example to kind of teach it how to, in context, right? Teach it how to decompose a specific task into, or sorry, I keep saying tasks, but decompose a goal into a series of smaller tasks. So yeah, I'm going to just paste this here, and then I'm going to write more around this. So I didn't even copy this, I guess. Okay. Paste. Okay. So no think. Okay. So let's write a prompt, a better prompt, so that it will understand what we want to do. So you are an expert GUI agent planner. You have the you have an elite ability to take in an overall user defined goal as a prompt and decompose it into a series of actionable steps for downstream applications, such as a GUI agent to act on. Okay, so the inputs are user prompts that defines the goal, and outputs are lists of granular actionable instructions that achieve this goal. Okay, so output format is a list of markdown bulleted instructions that basically that describes, right, the overall user goal. Okay, and then we can have an example here, and that's where we can use what we just wrote. So example, so the user prompt, and I'll just make this neater. User prompt decomposed task. Okay, so user prompt is to make the font size bigger, 24 point, and then the decomposed tasks could be something like this. Okay, maybe this will actually be better as like a system message, but yeah, let's make this a system message. Okay, so let's go here, and then let's go down and paste that there. And while we're at it, let's set temperature. Let's just make it to be 0. I don't know. Let's see, 0.5, because we're not really looking for super creativity here. Everything else, I think we can leave the same. Maybe we could allow for some repeat. So we don't want to penalize too much. But anyway, yeah, that looks good. So that looks like a good start. So here's a good prompt, and let's see how well it can do. So let's give an easy one. Okay, so no think, make the font size smaller. Let's say 12 point. So given this, and I'm actually doing pure CPU inferencing on really weak laptop. I just want to see how far we can get with weaker computers. So looks like it's already pretty good, right? So ensure that the document editing view is visible. Navigate to the toolbar, locate the font size dropdown, click on the font size dropdown, scroll to find 12 and click on 12. So this is actually a valid set of instructions. So let's just say if we copy that, is it the right format that we expected? And it is, right? So that's markdown list there for you. So that's a good example. So let's actually do something trickier in this case. So let's copy. Actually, we don't need to copy that. We'll just start a new chat and we'll specify no think again. Okay. And let's think of something else. Let's say let's make the title of our document a heading 1. So make the title of the document a heading 1. So let's see what happens. Let's see what it comes up with. So ensure that document editing is visible. Navigate to the toolbar, locate the heading style dropdown or the formatting toolbar. Click on the heading style dropdown, scroll down and select heading 1 from the list. So you notice here that this LLM is already very capable of decomposing tasks pretty well already. Part of it is that our prompts have been related to very common applications like word processors, right? So it conceptually knows things like headings and formatting toolbars and things like that. So in this case here, in context, like prompting really helps and can probably achieve most of what you want to do for the task decomposition. But if you become very domain specific, let's say your app is something that is very niche and there's not much information out there, and chances are LLM isn't really familiar with it, then that's where it makes sense to fine tune on task decomposition specifically for your application. And so, yeah, like a training data set, let's say for like fine tuning a model just for that, is going to just be like this, right? Give that prompt as input, and then output would be this list of steps. So in this case here, equivalently, right? So make the font size bigger can map to this decomposed series of steps, but same thing here, a user prompt can also say, I want the font size to be 24 point. That can also decompose back to these series of steps, right? So here already we have 2 training examples for us to teach the LLM what it means to change the font size to be 24 point. Now, it could be even more interesting in that we can generalize better, right, for font size manipulation, modification, whatever you want to call it, to be something like this. Font size and then unit, right? We could do something like this, and then, or we can even skip this altogether, and we can just do like a replace right here, and that would be like one other training example. Okay, and we can have like many variations of this, and eventually the LLM will learn during training to be able to speak natively to decompose tasks, right? So so what I want to do, like the overall goal here, and I'm going to eject this. Maybe I should save this prompt. Let's see, copy. And then I'll just save this prompt here. Okay. What I want to do is I want to see if we can take a very, very small language model, like in this case, Gemma 270M. So a 500 megabyte, 270 million parameter model, and see how well it does with task decomposition. So in this case, I'm going to give the same thing here again, make the font size bigger, 24 point, and let's see if it can actually follow those instructions. So in this case, yeah, so it doesn't really look like it knows how to do it. Either that or if I recall correctly, I think Gemma doesn't really understand system prompts. So maybe I can just get rid of this and see what happens. Let's see if I paste it here. And then I can also just say, okay, prompt. Okay. So let's see. I want the fonts, make the font size smaller. Let's say make the font size smaller. And then see what happens. So make the font size low. Make the font size to be 12 points. Okay. Okay. So it just it just regurgitates things in this case. It doesn't really do particularly well in understanding those instructions because I think it's just too small of a model to really grasp those instructions. So that's good because what we're going to do in the next, I guess, video or so is we're going to fine tune Gemma 3 270M to do what Quen 1.7b, a model that is, I don't know, like 8 times bigger than it can do, right? And I'm doing this purely on CPU, so it's already pretty fast at like almost 43 tokens per second. I only have a little integrated GPU here, which is basically being occupied with OBS right now. So let's see how far we can get, and it's very little memory, and so this will be fun. I just want to see if I can push hardware to the limits, do something useful. Anyway, that is what task decomposition is in a very high level way. And maybe next time we'll do something. Thanks.